Hello. Oh. Whoops. Right. All right. Welcome back. All right, you guys. I appreciate you being here and hanging out with me today on this Saturday evening. It's not always that easy to come in on your Saturday, on your day off, and sit down and do some programming practice exercises. But here we are, nonetheless. So if you are here with me, give yourselves a round of applause or a pat on the back. You deserve it. We could be out, on the town, as if we would ever, but we could be, you know. I like to think that we could be in an alternate life, but in reality, probably not. So, welcome everybody. I hope you're having a good day today. My name is Michael. Oh boy. We're going to be jumping into C programming, a modern approach today. We're going to be jumping back into chapter 4 and completing some of the exercises, or probably all of the exercises, and maybe the programming projects at the end of the chapter. So this could be potentially be the last stream of chapter 4, or we could break it up one more and just do the exercises tonight and the programming projects another time. I might break it up and do the exercises and then watch a lecture of the MIT or something. All right. Without further ado, let's go ahead and get started here. All right, everybody. So we're going to be jumping back into Chapter 4 of C Programming, a Modern Approach here, second edition by K.N. King. Let's go ahead and jump in and see if we can solve these exercises. So number 1 here says, show the output produced by each of the following program fragments. Assume that I, j, and k are int variables. Okay. So that's going to produce 3 divided by 5, or sorry, 5 divided by 3 truncated down, right? So it'll be a whole number. And then the modulo return value will return us what? Probably 2, no? Let's go ahead and find out. So let's go ahead and do int or include our standard io.h header file. Go int main, and then we're going to say void here. And let's go and say int I equals to 5. And j equals to 3. Okay, let's see what we can do here now. Let's just call printf 2%d %d for I divided by j and I modulo j. Okay, cool. Let's go ahead and do A. And then I'm going to copy this. B and C. Yo, MJ, how's it going? What are you hoping to do when you learn C well enough to use it on your own? Dude, honestly, I've been trying to think of that myself. I've been asking myself that question, MJ. I'm hoping that maybe as I learn some more tools that I'm a little bit more enlightened about what we can do, because honestly, everything I'm kind of thinking of can be done pretty much probably easier in Python and a lot faster. So I need to expand my knowledge into things that would be more, generalized or niche into C specifically rather than something else. So honestly, when we get there, I hope we can get there and figure that out as well. Hey, Jessen, I've been learning C++. C is goated. I love the syntax and simplicity. I'm thinking of learning embedded systems eventually. Nice, Jessen. I appreciate you coming in. It's great to hear from you again, my boy. Welcome back. How you been doing? What else have you been working on? Hey, and you too, MJ. What you been working on? So let's say this is I is 2 and 3, and then 7 and 8, and this one has a K value. K equals to 9. Okay, so then this is kind of spread these out a little bit. And we'll also put \ns here. Okay, so this one gets I divided by j, I modulo I, or I modulo j, I plus 10. Okay, pretty simple. I plus 10 for that first one. Oh, modulo by j. Interesting. Gosh, okay. And then C is 7, 8, and 9. And then it's I plus 10 modulo K divided by J. I plus 10 modulo K divided by J. Okay, so let's do some predictions. Right? Let me go ahead and get my calculadora out. Saturday, we're not trying to do math in our head. Okay, so we're going to do, in this first one, I divided by j, or floor division. So it would be 5 divided by 3. This gives us to 1.66, which would truncate down to 1 for this first value here. Then let's go ahead and say, right, 5 modulo 3. Now, dude, I swear I always have to look up the modulo because I always get it confused. I know exactly what it does, right, the remainder, but I always get it confused with the starting versus the order of it, right? So if we're taking 5 modulo 3, we're doing 5 divided by 3, which has a remainder. Oh my gosh. Hold on, let me see here. Yeah, so it is 2, like I was right earlier. So it just is like the 3 can only go into 5 once with a remainder of 2. Perfect, yeah, exactly. Now, so that's my guess here. We'll say A output is going to be, quote, I think it's going to be 1, and it's going to be 2, like that. Let's go here and do B output. So B output is going to go I, oh, this is just 1% D. Okay, so it's going to be I plus 10, so this is going to be first, so 12 modulo by 3. 3 goes into 12 4 times evenly, so that'll be a remainder of 0. Right? And then this guy will be, oh, I don't know, what does the modulo order of operations do with modulo? I think it'll go left to right, probably. So this will go 7 plus 10 is 17. Modulo by K. Oh, I don't know. This one's tricky. What do you guys think? Does the modulo... Let's go look up at our notes here for precedence. Our precedence, right? Okay, so here's this one. We have So these happen within the same multiplicative binary kind of scope here. So I believe that the associativity to one another would just happen in line left to right as these take place. So this one would happen. So my guess is it would go 17 modulo by k, which is 9. So that would be 9 goes into 17 once with a remainder of 8 divided by 8. So I'd say this is 1. That's my guess. Let's go ahead and find out. Let's see if I can go back up and pull all these. Will it let me? I don't want to. Alright, here we go. Let's go. Okay, this is going to be, we went on a programming project, so let's do, so we can go to exercises. There we go. Okay, so exercise 1 from exercise 1. This is going to be a chapter 4, though. Chapter 4. Oh. We got CD chapter 4 exercise 1. And now we'll run this. Oh, do I have to say? Oh. Right, I was redefining those. So then I need to define can I not do that either? Okay, its own expression. Okay, so now we'll go and do / chapter 4 exercise 1 exe 12, 0, and 1. Nice. Let's go. Let's go. We got it. That's exactly the output we expected. Nice. I'm happy with that. MJ says, I'm learning Rust right now. Justin says, just remember the closer you want to interact with hardware languages like C and C++ are always a great option. I would say Python isn't faster necessarily, but it's much more human readable. Also, I'm doing great. Currently learning C++, data structures, and design patterns. I'm also just made my senior project in C#. Nice, dude. What's C# all about? I've never really heard much about it. Hey, Gabriel. Hey, man, how's it going? How are you doing in C? I'm also thinking about learning with that book. Yeah, dude, jump alongside me here and read it with me. If I'm going to be reading it, you might as well too. And if you're going to be joining me here, you might as well be doing the practice projects and getting the work done. So jump on in and see if you can catch up to me. And yeah, thanks so much for being here. Sorry. Okay, cool. Let's go ahead and that is number 1. That was easy enough. Easy enough. Let's go ahead and jump into number 2. Okay, programming project number 2, or exercise number 2. Again, these you can find these notes on my GitHub. If you would like, they're linked down below. I also have a Discord with all of my resources as I've been teaching myself Python and computer science and C now from the ground up, from scratch. I'm learning computer science. I'm a human biologist or a biochemist. I have a degree in human biology and a minor in chemistry. And I work for a biotech company professionally. I manufacture and formulate biological controls that are used in like patient diagnostics and testing. And I've been teaching myself programming for a little over a year and a half, trying to gain new skills and keep myself going rather than just, vegging out and playing video games after work every day, all day. I decided to keep myself busy and try to take on new goals and new habits and see if I could learn new skills and see how far they could take me. So thanks for being here. And we're in C Programming, A Modern Approach, 2nd edition by Kay and King. Feel free to join me and do these practice projects alongside me. Oh, shoot. There's one more here we forgot. Oh, that's a bummer. Let's go ahead and throw this on real quick. So this one's going to be D. And this has I is 1, J is 2, and K is 3. And we go printf on the D, pause, 1 plus I plus 5, modulo by J plus 2, in parentheses, right? And then divided by K. Okay, so this is going to be 1 plus 5, this is going to be 6. J plus 2 is going to be 4. So 6 modulo 4 will give us 2. 2 divided by 3 will give us, that'll be truncated down to what? Just 0? Yeah. That's my guess. Let's go ahead and back up to this one and then run this one more time. Oh. We don't need to define K here. We'll just, there we go. Override the value. 1, 2, 0, 1, and 0. Let's go. Nice. Okay, let's keep going here. We got 15 of these bad boys we gotta try to bust out tonight. And then I'm thinking about maybe we play some, I'll hop out into my other PC, on my PC, and we'll play maybe some League of Legends or something. What do you guys think? Should we go full CS major and start playing League of Legends in our free time? Bro. Your boy's a jungle main. Got that Kane, got that Nunu, jungle fever. Alright. How's it going? Let's keep going. If you play League, what's your main? What do you do? Okay, I haven't played though in like 2 years. Number 2, if I and j are positive integers, does parenthesis negative I parenthesis divided by j always have the same value as negative I divided by j? Justify your answer. So if this always sets I to be affected by a negative out front, right? So in this case, if I is positive and j is positive, the answer would be negative because I would be, given a value of a negative in front, a prefix, or basically kind of multiplied by -1, essentially. Now, so that's if they're both positive. Now what happens if they're both negative? Well, this would become positive, this would become negative, giving us, is that how that works? Right, is that how that works? Do I have that right? So this would become positive, this would be negative, giving us a negative answer. So that is for if they're both negative. Now what happens if I is positive and j is negative? If I is positive, j is negative, the answer is positive. If this is negative and this is positive, the answer is positive. Okay, I think I need to write this down a little bit better. Let's do a comment like this. Okay, so for A, which is going to be -1 divided by j, or negative I, sorry. So if, we'll say I, j. So if A is positive, and we'll also go answer. So if I is positive and j is positive, our answer would be so if they're both positive and positive, our answer would be negative. Okay, if they're both negative, this would become positive, this would be negative, our answer would be negative. If this is positive and this is negative, this would be negative and this would be negative, giving us a answer of positive, right? And if this was negative, and this was positive, this would become positive, this would be positive, this would give us a positive answer. Now let's look out for the other scenario, where we have negative I divided by j, right? So in this case, I, j, answer, I would be, if I is positive and j is positive, the answer would be negative. If I is negative and j is negative, the answer, this would become positive, the answer would be negative. If I is positive and j is negative, I is positive and j is negative, this would give a negative answer in the parentheses, multiplied by a negative to give you a positive answer. And if it's the other way around, where I is positive and j is negative, well, this will be negative times negative will be positive. So in both circumstances, really, that's not what I was expecting. Were you guys expecting this? So in both cases, positive, that would be negative and positive, that would be negative. Negative would make that positive, that would make that negative. So this multiplies the entire result into a negative value. This multiplies just I into a negative value, which thus could affect the entire result. I'm going to get some feedback on this one. I am trying to evaluate if these are the same, and by doing a table, it does show the result. The answer will be the same in all cases. Let's go through this carefully and confirm. We can rewrite this as -1 times I divided by j equals to -1 times I divided by j. So this equals to negative I divided by j. That means that A and B are algebraically identical because B is exactly negative of I divided by j. Let's verify. Cool. So these are the same. Result. These are algebraically equivalent, it said. Algebraically identical. Okay. Cool. That was my answer to that one. C++ C# is a language made by Microsoft. It is great for game development especially, but it's often used in business world. It can be used to make apps of any kind. It's very fun. Also, C# is modern, basically like modern day C, like Python or Java, but modern. Have you ever tried Obsidian Notes? It's basically a markdown language app. Note is so amazing. I haven't ever given it a fair try. People have been suggesting it though like crazy. I've never played League, only online MMO I've ever played is Wizard 101. Mike CS major mode gaming, no showering, and same shirt for 3 days in a row. Yes, sir. You know how I do. We gotta get our washes worth. Pause. We gotta no. Okay. All right, let's go on to the next one. Number 4. Oh, sorry, number 3. Number 3. What is the value of each of the following expressions in C89? Give all possible values if an expression may have more than one value. Oh, gosh. Come on. C89. We'll do A. So in C89, all the possible values for the expression would have more than one value. So C89, let's go back up. We talked about describing the result when the division and modulo are used with negative operands is tricky. The C89 standard states that if either operand is negative, the result of a division can be rounded either up or down. For example, the value of negative 9 divided by 7 could either be negative 1 or negative 2. So this would give you either or. So it'd be truncated down, right? Which would be, so 1.23, or 1.29 is our answer, sorry. And be either rounded up or down. If I or j is negative, the sign of the modulo in C89 depends on the implementation. For example, the value of set negative 9, the modulo 7 could either be negative 2 or positive 5. Why positive 5? In C99, on the other hand, the result of the division is always truncated towards 0. And the value of the modulo has the same sign as I. Okay, so in C89, I don't really get this 5. Anyone know why in C89 does this negative modulo operation provide? Because obviously it would be, the one answer is obvious is 2, right? 7 goes into 9 once, or positive 9 once rather, and thus it would be 2, both the negative out front because it's negative. But why 5? Because 7 minus 5 is 2. This plus 5 is 4, negative 4. Okay, let's go see our examples. Or let's go see our practice problems here, exercises. Okay, so in C89, the truncation, it can either be rounded up or down, even with negatives, or is it always has to be positive? Oh gosh. With negatives is tricky. So with positives, it looks like it'll behave the same. Okay, so in this A example, the output will be right, this will just go down to 8 divided by 5. Let's do truncated down to 1. Let's do this. This is going to be C. Okay. A is going to be 1. B is going to be -8 divided by 5. Could go up or down. So it would be either -1 or -2. And C, if we did the 5 on this end, oh God. It's hard because I'm not using C89, so it's not like I can test it really. So if the negative is on the right side, I don't think it should matter. I think it should probably be the same as. Hey, whoa, hey, Justin, thanks so much. I think I gotta get going. I wish I could stick around for the streams more. I think you're very motivating and relaxing. Have a great stream, man. Thanks so much, man. Justin, thanks so much for the $5. Let's get some hearts up for Justin in chat here. You need a man. Get some hearts up here for you. Thank you so much, Justin. I appreciate you, and your hard work's gonna pay off. Our hard work's gonna pay off. Keep grinding. We're grinding together. I'm here with you. Thank you so much. I really appreciate that. Okay, so now if we do this, this should give us a positive answer, right? This should give us a positive answer. But does it either give you 1 or 2 still with... I'm going to ask this question in chat here. I want to get some more feedback. I am not using C89, so it can be hard to test. But I am trying to understand the differences when using negatives. I know that it will truncate or will divide and provide either seal or floor in C89, right? This dives right into the subtle historical quirks of C's integer division rules. Background: division and truncation rules in C. In modern C, C99 and later, integer division truncates towards 0. This means the result always chops off the decimal part. In C89, the rule was implementation defined, meaning different compilers could handle negative integer division differently. Specifically in C89, the result of integer division with negative operands could either truncate towards 0 like modern C or floor toward negative infinity and round down. So depending on your compiler, you could get slightly different results when negatives are involved. Let's break down each case. So an 8 divided by 5 is always 1. Since 8 divided by 5 is 1.6, the integer part is 1. No negatives involved, so it's consistent across all standards. Cool, we got that right. -8 divided by 5, now this is where the ambiguity happens. If truncating towards 0 in the modern rule, we'll get to -1. If flooring, rounding down, right, this will floor this value towards a negative infinity, and this will become a -2. Oh, I get it, right, because it's -1.6, and you're rounding down, right? But if you round up on a negative number with a decimal, you're technically making that number larger, right? And with truncation, you typically would remove that decimal, making the value smaller. So when you're doing division with a negative involved, right, if I were to truncate this value all the time, it would give me a value of -1. But because, I'm technically like lowering the value in my mind, in some interpretations, I could truncate this to -2 by rounding down towards rounding up down to infinity, right? Going even more negative, which is follows that kind of truncation. It goes to the whole value, but the smallest whole value that it could make. Okay. So this one would give you -1 or 2. This would give you truncate towards 0 with -1 and floor towards -2. Great. In this one, both our negative signs cancel out, so rounding gives you just the integer part of 1. Okay, so the negatives do cancel out in this case, so it's just when it's either or. So it'd just be 1. Got you. Okay. That makes more sense because when we truncate numbers with floor division, we're always making values smaller. And if we were to truncate or remove the decimal value from a negative division, we would be making the value larger. So some might interpret that as incorrect from the norm when so you would go floor it to a smaller value in both circumstances in some interpretations. Did that really not work? Hello, 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 hello. Really? Dang. Hello, 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 hello. Dang. Can't have my conversations. C89 is weird. I think the different outputs is only dependent on the compiler you use. If you compile using the same compiler, outputs different consistence. You're doing well, bro. Keep pushing. Hey, thank you so much, man. I like the kind words. Also, I've been using GCC for compiling its backwards compatibility prior to C versions. Just use the GCC-standard equals C89. Oh, okay, so you can set a flag to switch back to that one. Oh, interesting. So it kind of makes sense that interpretation could differ when we truncate. We make the value smaller, but with negative, removing the decimal makes it bigger. So it kind of is a little strange. That's a good object. It shows that you're thinking about the geometry of the number line, not just the arithmetic. Cool. Nice. All right, let's keep on pushing here. Let's go this one now. Okay, number 4. Okay, exercise 4. We now have to do this. Repeat this for C99. Okay, easy. So this will always floor to 0 in C99. So this one will go -1, right? -1, -1, and 1, right? It'll always floor to 0 in these cases, correct? Let me just quickly do this. Let's just, we can test this by going. We'll do printf. We'll do, okay, so this is going to be -8, -5, negative and negative. I always forget the return 0, shoot. Exercise 4. Oh. 1, negative 1, negative 1, and 1. Perfect. Nice. Sweet. Hey, Gabriel, how's it going? I was ready to go to bed, but maybe I should really start with the book. Good inspiration. Yeah, just like, the first chapter is only like, it's like less than 10 pages. Just like try to bang out the first chapter here while you're sitting with me. If you want, you can go back to my upload, and it's only like 15 or 20 minutes to follow along and read the first chapter with me. Just try to set a goal to read one a day, at least as far as I'm going, and then you'll catch up with me pretty quick, as I'm not reading one a day every day because I'm doing these exercises and stuff in between and some other courses and stuff. But if you do one a day, you'll catch up to me pretty quick, and it's not too hard so far. It's been pretty nice. It's been a lot of fun. Okay, that was number 4. Let's keep going. Number 5. Okay. Let's keep this on. All right. Mahan, yo! Dude, where you been? You quit programming? What's up, dude? How's it going? Bro's been MIA. All right, here we go. We're doing number 5 here. What is the value for each of the following expressions in C89? Oh, no. Modulo 1. We're going to be bad at this one, I think. Okay. Okay, so 8 modulo 5 in C89 in both positive cases will give us a value of 3. Now, I'm going to have to ask, why is negative 9 modulo 7 either negative 2 or 5 in C89? I don't get the 5. When C89, when you compute this, it must satisfy the mathematical relationship of this. But in C89, did not define whether divisions round towards 0 or toward negative infinity floor, so depending on which rule the compiler follows, both the quotient and remainder changed slightly. Let's analyze this. In case 1, which truncates towards 0, the modern rule, this happens, and then we get negative 1 as what's left over. Truncate, now plug this back into the rule, and you get this. Case 2, when we floor towards negative infinity, we get negative 2 for this value, and by plugging it back into this rule, it gives us this 5. So it strictly depends upon this rule that you plug things back into to satisfy the modulo requirement. Both are valid mathematically since C89 allowed either one. And C99 is truncated towards 0, so the result is now always this. Think of the remainder as what's left after dividing completely. If division rule forces the quotient to go lower, you've taken away too much. The remainder must be positive to bring back the total value to negative 9. Okay, so in this example here, is if we do negative 2 for this, or no, let's say we get negative 2 for this value here. Oh, so you basically just apply that value against this one. And now I guess that's the relationship that I can find. So if this was negative 2 here, 7 minus 2 would give you 5. But I think it's more specific. It has to go into this equation here of what's the remainder. Okay, let's try it. So what's that equation then? Let's go look back up here. There's that equation that it must satisfy. What is that expression for modulo? A equals to A divided by B times B plus the remainder. Okay, so we'll do A equals to A divided by B times B plus A modulo B. Right? That's the expression that is used to satisfy this, okay? So let's look at these examples in this problem. Like this one. Okay, here we go, 5. So 8 modulo 3 positive. So this will give you, and both are positive in this case, so this will give you a remainder of 3, I believe, right? And then in this case, we first perform the division of 8 divided by 3. And that gives you, right, a value 2.67. And if that gets either floored down or that gets truncated, or it gets rounded down towards infinity. So it's either -2 or -3. So -2 or -3 is the remainder. So R is equal to -2 or -3. So if we then say, which is, if we satisfy this, so this would be the -8 divided by the 5, which is, well, in this case, does it truncate it here? Oh, so that would be, but that's this here, -2 or 3, plus the remainder times B. And so if B is 5, so what would it be like? It'd be -2 times 5 plus the modulo now. Oh, I'm trash at this. In this positive case. Now example with negative numbers. So -9 divided by 7 is -1 in the newer versions. Okay, so you just do the truncation. Okay, so you always, then it'd be this. In C89, this could differ because some compilers do default to keeping this. -2 for this value, which equals to -9. Oh, so you're solving for R, right? Got you. So if we say that A, let me write out the formulas here so I can kind of see them better. 8 modulo 5 is going to equal to 3, okay? -8 modulo +5 is going to equal to, we're going to go down here and do this. So we'll say you do, we would say -8 divided by 5 gives you either, right, be 2 or, so be -2 or -3, right? So then we would plug this into our equation here and say negative 8 equals to our this value that we plugged in, so it would be negative 2, times our b value of 5 plus r, plus a modulo b, which is what we're solving for. So if we do this, we negative 10, right, plus negative 8, or sorry, we do negative 10, add that over, that would be positive 2. So this would be 2 is equal to a modulo b for one of these cases, in this case. Now you would have a second option here where you'd say negative 3 in for this place here. So it'd be negative 8 is equal to negative 3 times 5 plus a modulo b. Right, so this would be negative 15, right? And that would be 7. So it would be 7. But I thought we have to have a negative in here somewhere. Let's work with this example. I want to try to see with this example here. Let's work with this one. So negative 8 and here's negative 8 divided by 5 times 5 plus r. Perfect. Okay. So in one case, so I have the first part wrong. It's 1.6, not 2.6. That's my bad. So it'd be negative 1 or negative 2. So we do negative 1 here, negative 2. That would give us 2 is equal to a modulo b here. And then in this case, negative 5, negative 3. Yeah, because it's 3, this will be negative 3 or 2. Nice. So this is just A divided by B here, which equals to nice. All right, cool. That's that one. Let's get caught up on some chats here. In Python, both languages, you can achieve the same thing. Hey, Hall, welcome back in, dude. How's it going? Hey, how to? I appreciate you coming in. I like OOP in Python. I like making classes and stuff. What made you decide to read this book? I wanted to get better at Python. I know it might seem kind of strange, but I wanted to understand what was going on in Python and to get better at it. I wanted to um, you know take a understand, take a peek under the hood, and you know stop kind of saying, oh, I think why that's happening, or I think why that's what's going on. I wanted to be more solid and translate that. So yeah. All right, cool. Let's keep going. Let's go C. Yeah, C89 is not taught anymore, but it's good for us to know about, right? We want to definitely know about these things in case we ever have to experience them or face them. Never know. All right, let's go here for this one. So the answer should be the same in this case. So this should be same as B, I think. And then D, this will just be the same as A. Well, this goes, I think if this is the same as A. Okay, let's get some feedback here. Let's go through these here. So in case A, okay, so in no negatives here, there's no ambiguity. 8 divided by 5, 1. Plug that back in, you just get here because it's positive, right? Oh, so it really does depend. Okay, so it is just positive. Oh, I think I overrode that up there on accident. Okay, now let's look at the next one here. Now for this one, it's either -3 or +2. Dang it. Okay, so we got -8 divided by 5 is either -1 or -2. Okay. +2, +5. Oh, I did have that right. Yeah, sorry, -3 and 2. I was looking at the wrong thing again. Right, I had it right. Or 2, right here. Okay, then in C, now the divisor is negative. Oh wait, so this actually, the divisor isn't, so that something's different. Oh, interesting. So it flips. So when the divisor is negative, this would go -1 or -2 still for A divided by B. And 8 is positive when you plug it back in. Ah. So it'd be A divided by B, right? And A is 8 divided by -5, right? This would give you an answer of either -1 or -2. So when we plug that back into our equation of 8 is equal to -1 times -5 plus A modulo B, this would give you -5, +5, this would give you 3 is equal to A modulo B. Got you. Okay, so you gotta plug it back in. It's not the same because your sign flipped, and remember I had that thing in there where you have to plug this back into that equation. Okay, so then in the case for the -2 here, it'd be 8 is equal to -2 times -5 plus a modulo b. And this would go to +10 less than, would bring you to -2. It's equal to a modulo b. Right? Cool. So the answer for C then would be 8 modulo -5 is equal to +3 or -2. Okay, and then in the case for D probably would have the same effect as A though, because those would just cancel each other out. Both operands are negative. They have the same computation, a +1. So let's go to negative. Oh, but it would be -3. Oh, it's the opposite, right? Oh, interesting. So these aren't as like. So there is some. You got to make sure you plug it back into these equations to make sure. Okay, so then let's say we have -8 modulo -5 is equal. So then we have A divided by B, which is going to be -8 divided by -5. And this is going to equal to both cases. It says both cases will be 1, right? Truncated to 0, truncated towards infinity will be 1. Yeah, both cases would be 1 because it would go to positive 1 point something. Truncated down would be 1. And then truncated to infinity, or negative infinity, I'm sorry, would be 1 as well. So then if we plug in, so this would both be 1. So then we would say, -8 is equal to 1 times a -5 plus A modulo by B. This would be -5. Add that over. Become +3. No. -3. Add the -5 to add the +5 to -8. Saturday, guys. We weren't expecting to do math today. Okay, cool. So that'll give you that. So this will be -3. So let's show this to be a little bit more specific. A divided by B. So this would be 8 divided by 5, which will truncate to +1. Right, and then plug this back in. 8 is equal to 1 times 5 plus A modulo B, or the remainder value we're solving for. This would be 5. 8 less than 5 would be +3 is equal to A modulo B. Cool. Just wanted to show those out a little bit more. Nice. Let's kind of get these separators here so it's a little bit easier to read for everybody on the notes. Why did D go all over here? Nice. All right, that looks good. Sweet. Do you think authors write certain chapters just to pad out the book? I don't know. Like if you're like, I think he's just being thorough. Like, honestly, I think he's just being thorough with giving you lots of practice and lots of stuff. Like, I mean, like, why not? Like, it really does no harm having more. Like, in all honesty, I think it would hurt you as an author to have missing information or less information. Like, if anything, having more, like, doesn't really hurt you at all, unless it, like, starts to, where'd my shoe go? Lost my sandal. There it is. Okay, cool. That was a longer one. Let's go and try this one. So C89 is a little bit trickier with how it handled some of these operations for sure. Okay, let's do number 6. So we're going to repeat this, but for C99 this time, which is going to be a lot easier, hopefully. Okay, so A. Hey, who's that? Seaman! Thank you so much. I appreciate you so much for coming in and subscribing. If you guys aren't subscribed yet, feel free. I stream every single day almost after my 9-to-5 job and on the weekends. Thanks so much as we teach ourselves computer science and programming. Yeah, I've heard of computational biology and stuff. Honestly, though, like that major seems even more, that field seems even more competitive than just software engineering. I've seen more people complain about lack of like bioinformatics and computational biology jobs than I've seen about software engineering jobs. It's kind of crazy. Okay, let's do 8 modulo by 5. This is going to be positive 3. It's pretty easy with C99. Okay, negative 8 modulo by 5. It's going to equal, so this will be A divided by B, right, which will be negative 8 divided by 5, which is going to equal to, this will truncate down to negative 1 and C99. Then we plug this back in for our equation to negative 8 is equal to negative 1 times negative 5 plus A modulo B. This gives us positive 5. Subtract over, oh sorry, it's positive 5. It gives us negative 5 plus over there would give us to negative 3 is equal to A modulo by B. Nice. So this would be negative 3. Now in C, we have 8 modulo negative 5 now. This is going to equal, so let's do A divided by B, which is going to be 8 divided by negative 5, which is going to be equal to negative 1, right? We're doing C99, which will remove the decimal from the value in integer division, or just division here. We are then going to do 8 equals to negative 1 times negative 5 plus A modulo B. And this will do positive 5 less than 8 would bring us to positive 3. Really? Yeah, it makes, actually, yeah, because that one's negative 3. It's interesting how these work. They're a little bit of kind of a brain teaser. Negative 8 modulo negative 5. So this would be positive 3. So if we do A divided by B, which is going to equal, or which will be negative 8 divided by negative 5, which will be 1. We then do negative 8 is equal to 1 times a negative 5 plus A modulo B. And this gives us negative 5 plus 5 over will bring us to negative 3 is equal to, really? -3. Well, yeah, that makes sense because you have 3 remainder in the negative side. Let's try it for C99. Are my attempts. Alright, cool, let's check here. 8 modulo 5 in C99 will give us 3, correct, nice. -8 modulo +5 will give us -3, correct. +8 modulo -5 will give us +3, correct. -8 modulo -8 gives us -3, correct. Let's go. Let's go. Okay, so if they're both negative, the answer is negative. The negative sign follows the first character, it looks like. Or the first value. The sign follows the first value. Exactly. The simplest way to remember it is that the sign is always the dividend A. So here's a little tip, like hint. In C99, the sign of the first value is the sign of the remainder. Is that always true? I was asking yesterday about what is the best cell/protein simulator. What is the cutting edge commercial tool? I know there's a lot of there's some of those out there, like AlphaFold protein simulations and stuff like that. On this channel, we simulated absorption spectroscopy and paper chromatography. So if you'd like to go back to my previous streams or go to spectrosim.com or chromaplot.com, you can see those simulations and run them for yourself. Just know that it's being hosted on a free server, so it's pretty slow for the response times. The code is fast in itself, but that initial response time is throttled pretty heavy, and it's honestly makes it kind of unusable. The server. Okay. Number 7 here. We're cruising. We keep going, guys. Thanks for joining me here. Today is November 8th. I appreciate you guys being here. If you guys are studying C programming, give yourselves a pat on the back. Oh, hey, sorry, Burger. I don't want to interfere too much with the journey, but Jens Gusted had released his book Modern C, a revised edition capturing new features of C23. He's on a standard committee and also communicates a lot of best practices in it. That's really cool. Yeah, we'll have to check that one out after this one. I have no problem. Maybe I just was recommended this one because it has a lot of really good examples for modern C and 99 and above, and also letting you know about the past too. But then I think I want to get another book like what you're talking about for maybe another more advanced version, and dive into that one next. So yeah, that'd be great. Put that book in the Discord and the community resources suggestions. That'd be great to have it in there for future. Okay. 7. The algorithm for computing the UPC check digit ends with the following steps. Subtract 1 from the total, compute the remainder when the adjusted total is divided by 10, and subtract the remainder from 9. It's attempting to try to simplify the algorithm by using these steps instead. Compute the remainder when the total is divided by 10. Subtract the remainder from 10. Why doesn't this technique work? Well, I mean, it just kind of seems kind of intuitive for like order of operations. Like you're subtraction and multiplication and division and modulo do not have the same precedence. So by deliberately subtracting, ahead of time, this is kind of the same thing as having a parentheses around that value, and then you're computing these in line, right? And then subtract the remainder from 9. So by combining the subtraction with it just kind of would throw things off, in my opinion, right? Let's go ahead and get some feedback here. What do you guys think? Give me your guys' answer. What do you guys think on number 7 here? Because we subtract 1 at the start in its own step, it's like having parentheses around it. It makes sense too because it's on its own line in the description given. The second or incorrect option combines the subtraction and multiplication when they do not have the same associativity. Exactly, you're thinking about it the right way. Let's unpack it a little bit more clearly. The UPC check digit algorithm subtracts 1 from the total to make an adjusted total, and then computes a remainder based off of 10, and then computes 9 minus that remainder. The tempting simplified version is to take R, do the total divided by 10, and then subtract 10, the remainder from 10. Why this doesn't work? The subtraction of 1 at the start is crucial. In the original algorithm, subtracting 1 before taking modulo 10 shifts the number down so that when you subtract the remainder from 9, it produces the correct check digit. If you skip the initial subtraction and try to just subtract the remainder from 10, the alignment is off. The check digit will be off by 1 in many cases. Intuition of the parentheses. Thinking of it as grouping like this. The operations are not associative. Subtraction and modulo do not compute in the same way addition and multiplication might. The parentheses matter. So total minus 1 modulo 10 is subtraction first, then modulo, and then total modulo 10 is modulo first, and then subtraction. These produce different results. Can you rephrase my answer for a little clarity? The reason the simplified method doesn't work is that the initial subtraction of 1 in the original algorithm is essential. In the original steps, you first subtract 1 from the total, then take the remainder modulo 10, and finally subtract the remainder from 9. This order ensures check digit is correctly calculated. It's tempting to simplify. The tempting simplification tries to skip the initial subtraction, instead just subtract the remainder from 10. However, subtraction and modulo operators are not associative, so changing the order alters the results. That's kind of what I was saying. Subtraction and modulo operators are not associated, so changing the order alters the results. In other words, these do not equal one another. I like this. So 9 less than total minus 1 modulo 10 does not equal to 10 less than total modulo 10. The parentheses matter, right? The parentheses matter. Subtracting 1 first shifts the total before taking the remainder. Skipping that step produces an incorrect check digit. Nice. Unfortunately, div from the standard library or the division and remainder operator in succession doesn't necessarily correspond to underlying index or listed div on x86, which is go. Okay, let's keep pushing here. 8. Would the UPC program still work if the expression were this? Oh, I think that's what we just did. Nine minus total minus one. Oh, but this one is a little bit different, right? So this isn't just what would this be if we plugged in values? So if, let's say total is 10, this would be 9. This would be 0. This would be 9 minus 0 is 9. So this is 10, modulo 10, 1, no, 0. 10 minus 0 is 10, modulo 10. It's 1, oh, sorry, 0. So this would be 10 minus 1, 9, 0, 9 minus 0. No, this might be 9. This might be 0 as well. 9 modulo 10 is 9. It's just the value given, right? You have 9 values left over because you can't actually modulo 9 by 10. I think, right? Yeah, that would give you 9 back because you have 9 values left over because 10 actually never went into 9. So this would give you 10 minus 1 is 9. 9 modulo 10 is 9. 9 minus 9 is 0. 10 modulo 10 is 0. 10 minus 0 is 10. 10 modulo 10 is 0. Let's try like 5. 5 minus 1 is 4. 4 modulo 10 is 4. 9 minus 4 is 5. 5 modulo 10 is 5. 10 minus 5 is 5. 5 modulo 10 is 5. Yes, I think so. I think it would. I think this is true. I tried 5 and 10 for the total, and both are equal. Oh, I'm throwing. So 10. Wait, what? Seems like to match some totals like 5, but fails for others like 10. Okay, so this is 9 minus 9 modulo 10. 9 modulo 10 is 9, I thought, which is 0. Okay. Why wouldn't this work? So it clearly doesn't work. There's something like obvious in the expression. So obviously you're... No, because you're modulating by... This is kind of the same thing as what I was saying above. Is you're modulating by 10 before you're actually doing the subtraction. So you're off by 1 in some cases. So no. No. This is similar to problem exercise 7, where the total needs to be subtracted by 1 before taking mod 10. The replacement would be off by 1 in some cases. So, right, this is similar to before, where we are not taking 1 less than the total before mod 10. Just like the initial subtraction of 1 matters because it shifts the total before taking the modulo. Skipping that step, as in 10 minus total, the modulo 10 changes the result for some totals. So let's see here. This is okay, so let's see what it had to say. It said, this is similar to exercise 7. The total must be reduced by 1 before taking modulo 10. Let's just do this. Okay, nice. Let's keep pushing. Let's keep pushing. You guys are here. We got 15 people in here tonight. If you guys could leave a like on this Saturday evening, I appreciate you joining me here. Been streaming for an hour and a half so far. If you guys are enjoying the C programming, I think you guys let me know. All right, let's keep going here. Okay, number 9. Show the output produced by the following program fragments. Assume that k and ij and k are int variables. Okay, cool. This one's gonna be fun. So let's do int main void, and let's open up this. Let's go also up to the top, and let's go ahead and include the standard io.h header file, and then let's go ahead and do int I, j, and k, and then let's say I is equal to 7 and j is equal to 8. Let's then say so then we're going to say this: I is equal to I multiply equal j plus 1. Okay, what do we think this is going to output? Well, if j is 8, we're going to add 1 to j. No, interesting. Actually, this is kind of interesting. Would the I mean, in Python, I know what would happen, right? But would we... So would this go to 9 for j, or would this do multiply and then add 1 to j? No, I think it would do the assignment last. Right, the assignment has last precedence, or last associativity, precedence, yeah, I think so. So it'd be 9 times I, which is 7, right? Which is what, like 63? Forgot. I can't do my multiplication. Yeah. and that would set I equals to 63. Something like that. So, and J would be 8. J would not be a changed assignment here, right? We're just adding one to J in this, and then using that to update the value of I. We're not actually reassigning J. So let's go ahead and call that printf for the two integer values, I, J. And then we'll also do a \dn here. So output for A output. All right, this is going to be A. Okay, so I think this is going to output 63 and 8. Okay, let's try B. Oh, this is going to be a part of A as well. So B, we're going to assign I is equal to J. Oh, wait. Oh, yeah. I is equal to J, which is equal to K, which is equal to 1. So K is going to become 1. J is going to equal what K is, 1. I is going to equal what J is, which is 1. Now I'm curious. This is going to set all of these values to equal the same place in memory as this K value. Oh, this is going to be interesting. Okay, so let's do I plus equals J plus equals K. Print F %D %D J or I, J and K. Let's go B output. What do we think this would be? Let me go back up. See some of my notes here. Yeah, so you would just associate right? Okay. Then if you assign them equal to one another here, okay, so they would all equal a value of 1. Okay, so they would all get a value of 1. This would be K, 1. J is going to be equal to 2. I is going to become 2 plus 1, which would be 3. So this would be 3, 2, 1. C. I is equal to 1. J is equal to 2. And then K is equal to 0. We're going to have I less equals to J, which is less equal to K. We're going to print F, the same thing here. Hey! I like this one. No. Yeah, this is groovy. Let's turn it up a little bit. Get some dance emojis going. Yo, what's going on, everybody? We got 19 people in here. How's everybody doing? My name is Michael. I appreciate everybody for joining me. We're doing C Programming, a Modern Approach, doing these exercises at the end of Chapter 4. We've done live reading on this channel of all these chapters, so if you want to go back through and listen to the audiobooks of them, please go find them on my channel. I've been completing the entire book live, so appreciate you guys being here and joining me. We're working on this one here. So let's go C output. And this is going to be, what do we think this is going to be? So k is equal to 0. Oh, wait. I think I wrote the wrong one. 1, 2, 3. Okay, we're looking at this guy here. Woo! Hey! Right up. I like this one. Let's get a little vibes going. Look at that shoulder. Those are my moves. Sounds a good one. Okay, let's keep rolling. So k is, so we're going to take j is going to be reduced by 3. So 2 minus 3 will be -1. So j is going to become -1. I is going to be reduced by -1. So I is 1 minus -1, so plus 1. So I become 2. So it'll be 2, -1, 3, I think. We'll see. That was a good one. Should we replay that one? I'm going to go for a replay on that one. Yeah, I like this one. All I imagine when I hear this is, you know, like on Instagram Reels or on like TikTok, whatever, when people like post those GIFs of like Jay-Z going, or like Winnie the Pooh doing like the dance moves. Let me see. Winnie the Pooh dance move GIF. Winnie the Pooh dance VR GIF. I think it's VR, chat. Okay. No, that's not it. Which one is it? Oh, it's here. Yeah, I like this. I like that. Alright, let's keep going. We got 25 people in here. We keep growing, we growing, we up. Oh, yeah. Alright, let's keep rolling. We're going to go I is equal to 2. J is equal to 10. Or 1. K is equal to 0. Let's do I multiply equals to j, which multiplies equals to k. And we're going to print f, the same thing as above here. Okay, so what's going to happen here is k is 0, which is going to be multiplied equaled by 0, 0. That was pretty easy. All right, let's try this. Let's test this out. Here we go. This is exercise 9. Oh no. Hey, we compile. Okay. Oh, hold up. We gotta get some backslash ends here. Okay, we're looking for 63.8. Nice. 321. Nice. $63.8. 321. 2 -1 3 0 0 0. Let's go. We got C strings down. Hey Crimson, why'd you pick this book and how are you liking it? I've got a lot of recommendations for this one. I wanted to know more about not only like modern C, but a little bit more about history of C as well. So it gives comparison for C89 and C9, C88, right? 88, 89, I think so. No, C89, 99. And then also has a lot of good programming practice problems and projects. A lot of people said that when they got to the back end of this book, they felt really comfortable working through C, writing scripts in C and stuff. So I wanted to take that, and I did Python Crash Course, which had a very similar flow of kind of like post chapter problems and exercises to complete, and had some in text practice problems and exercises and stuff. So it was pretty helpful. Okay, cool. That was number 9. Let's keep pushing. We're on a roll. Number 10. Show the output. Woo. Show the output produced by each of the following program fragments. Assume that I and j are int variables. Okay, so similar to what we had before. Let's include the standard io.h header. And let's go int main void. And we're going to come in here, we're going to return 0. Okay, so our A, or we have I and J, looks like, that's it. So int I and J. Let's go here, do A. So I is going to equal to 6. J is going to equal to I plus equals to I. And then we're going to call printf to %d space %d I and j. Okay, so let's think what's going to happen here. Woo. Okay, so I is 6. We're going to add 6 to I, so I becomes 12 and j becomes 12. So we're going to print 12, 12. Maybe. We'll find out. We sure will. B. So in B, I is equal to 5. And then j is equal to I less than or equal to 2 plus 1. And now we're going to print f for the same call. And we're going to comment and do B output. Okay, what do we think B's output's going to be here? So if I is 5, within this parenthesis, we're going to call I less than equals to 2. And so I will become 3. So I is going to be 3. J is going to be 3 plus 1, which is 4. That's my answer. Let's keep going. C. I is equal to 7. And j is equal to 6 plus I equals to 2.5. And then we're going to printf to the same call. Okay, so our C output is going to be, I is going to become 2.5 in this statement here. And then we're going to add 6 to that, so it'll be J is 8.5, and I think I is 2.5. We'll find out. D, I is equal to 2. J is equal to 8. J is equal to I equal to 6 plus J equal to 3. These are getting kind of crazy. I don't think we should ever do these, but I think it's just trying to get you some practice with understanding how these work. I don't think it's ever wise to actually do your print statements or, you know, expressions like this, right? Probably just to create new variables and reassign them. So we need backslash n's though as well. So what do we think the output's going to be for here? Let's try to figure it out. So I will become reassigned to 6 in this statement. J becomes reassigned to 3. I is at 6, so we say I is 6. 6 plus 3 is 9, and J gets assigned to that value at 9. Interesting. I want to see if we're right here. I am curious. Okay, let's try it out. This is exercise 10. Ah! Okay, so you actually can't do this. Oh yeah, you can't assign I to 2.5 here, it's a int. So this gives you error, and then this one gives you multiple sequences modified to J. You can't modify J within the same modification. So this is going to give you an error where, so the C output is this. And then the D output, we can't assign J within the assignment of J itself. That would make sense. Let's get some feedback on these ones. Let's carefully analyze our code snippets. Part A. Part A would print out 1212, perfect. Part B would print out 34, perfect. And I is an int. Assigning 2.5 to an int truncates the decimal, so I is 2. Oh, so it still will output? Oh. So these were the errors I got. This compiler warnings match what we predicted when analyzing your code. Let's break them down. I is declared an int. Assigning 2.5 to it truncates the fractional part, so I becomes 2. The compiler warns because you're assigning a double literal to an int. It may not be what you intended. runtime behavior I is equal to j is equal to 6 plus 2, which equals to 8. Multiple sequencing modified to j. Here j is being modified twice in the same sequence. C standard says this undefined behavior. The C compiler doesn't guarantee what happens first. Interesting. So mine didn't compile. It gave this warning, right? So some compilers may bypass these warnings, I guess, but okay, I think we're fine on that one. What do you guys think? Okay. 11. Show the output produced by each of the following fragments. More of this stuff. Okay. Let's just I, J, and K are int variables. So A is going to be okay, so A, what we're going to have is I equal to 1, and we call printf to %d space, and then we're going to insert I plus plus minus 1, and then we're going to call printf to I here. Okay, so this one's going to print, so I plus plus, this is going to modify the value of I after this on our next like stop marker or whatever, like that's baked into the C internals. So this plus plus that happens afterwards, or postfix incrementation, will take place after this line happens. So think about like at the end of a loop, when you do I plus plus, that line ends and the loop starts over, and I is now a new value, read at a new value. But in this line, I is going to be interpreted as 1. And then in this line, I will increase. So I plus plus will say 1, minus 1 will return 0 into this first integer, and then the second integer will reflect the I plus plus, and we're going to say this is going to be 1. Or sorry, this is going to be 2, because we're going to be increasing it. Okay, let's try the next one. I10 j equals to 5. We're going to do this here. I'll just copy this. Printf %d I plus plus minus plus plus j, and we're going to insert %d space %d and do I and j. Okay, so what's going to happen here? I is 10, so 10 is here and 5 is here. This is going to plus plus the 5 in this line, so j is going to increase to 6 here. This is going to be 10 minus 6, so this first one will be 4. Then we print I and j. I increases to 11, and j, which was 5, became 6 in this line, and this is 6 here. That's what I think for that one. Okay, C. We do I is equal to 7, and j is equal to 8. And then we do this printf %di plus plus minus j minus 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 j. And then we insert I and j here. So I is 7. I is 7 here and gets used as 7 in this line. 7 minus 1 less than 8 would be 7 minus 7 is 0. So I'd say we get a 0. So I becomes 8 in this line, and then j is at 7. So this would be 8, 7. D's output, I is 3, j is 4, and k is 5, right? We're going to call printf on %d I plus plus minus j plus 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 negative negative k. Okay. And then we're going to put in %d here and then put in k. All right, what's happening here? I is being treated as 3 in this line and then incrementing to 4 in this line. So right off the bat, we know what to do with that. So I is being treated as 3 in that line, but then being incremented to 4. So let's do I here. So for the first value though, j is also being incremented postfix, so j will become 5 in the second print, and then k is being incremented downwards in this line here, and so k will be 4. But used in this line, we have 3 plus minus 4, so that'd be negative 1 plus 4, right? So this is 4 here, 3 minus 4, negative 1, plus 4 gives us a positive 3. Okay, let's try this. Okay, that compiled. That printed literal \n. Oh, it's a forward slash. My bad. Okay, so we get 0, 2, 4, 11, 6, 0, 8, 7, 3, 4, 5, 4. Let's go. Let's go. Woo! Nice. All right, that's that one. Moving up. You guys are here enjoying the stream. If you could leave a like on it, I really appreciate you. If you guys are new here and want to subscribe and hang out with me, I stream almost every single day. At least that's my goal. I'm trying to teach myself computer science and programming and compound this learning with book reading, projects, courses, all for free, all from scratch. So thanks so much for being here. Okay. We want to show the output produced by the following fragments. So let's copy our code here, kind of into the same template here. We have an I, a J, and that's it. We don't have a K value. So A is going to be I is equal to 5, and J is equal to plus plus I times 3 minus 2. Okay, and then we're going to print out both I and J. Cool. Okay, so what's going to happen here? I is 5. I has prefix incrementation here, so I becomes 6. And we're going to do 6 times 3, which would be 18, minus 2 would be 16. I think that's what's going to happen. Okay? And then we're going to print out J. Oh, I'm sorry. J is 16. I is going to be 6. Okay, and then in B here, we have I is 5. There's no J value. Oh, headphones are dying. No. J is equal to 3 minus 2 times I plus plus. And now let's print out these guys. It's the same thing. Okay. Ooh. Okay, so what do we think is going to happen here? This is postfix incrementation to I. So I will increment afterwards. So we'll use 5 here. 2 times 5 is 10. 3 minus 10 is negative 7. But for I is going to be 6 and negative 7, I think. I'm sorry. We're going to use 5 here. Yes, 5 times 2 is 10. 3 minus 10 is negative 7, which is the J value. I is 5, which gets incremented postfix here and printed out here as 6. I think so. C, I is 7. Perfect. And J is 3 times I minus minus plus 2. So J is equal to 3 minus 3 times I minus minus plus 2. All right. So what's going to happen here when we print out I and J? So I is 7. We're going to postfix reduce I down, but we're going to use 7 here. Yeah. So 7 goes here. Times 3 is 21 plus 2 is 23. So that's J. J is 23. I, on the other hand, is 7 minus minus postfix 6. Okay, and then in D, I is equal to 7. We're going to call J is equal to 3 plus minus minus I times 2. And we're going to print I and J. Okay, so D, 7 is going to be prefixed reduced or decremented. So this will be 6 in this place. Times 2 is 12, plus 3 is 15 for J. And then I is going to be 7 minus 1, which would be 6. So let's look here and try this. Open here. 12. 12. 12. Okay, 6, 16. 6, negative 7. 6, 23. And 6, 15. Let's go! Ha! We out here. We getting this. That's like 3 problems in a row we've gotten right. Let's go. Okay, 13. Only one of the expressions plus plus I and plus I plus plus is exactly the same as I plus equals 1. Which is it? Justify your answer. Woo! And this is a fun one, right? So plus plus I is prefix incrementation. I plus equals 1 will update I in this line, which will happen to be plus plus I. I plus plus will not save I as 1 greater in this instance. Okay, I think that I plus equals 1 is equal to plus plus I. I say this because plus plus I is prefix incrementation. So the I variable is increased by 1 in line. I plus plus is postfix incrementation. So the I variable is increased by 1 in the next like sequence step, usually next line, right? Something like that. Okay, I plus equals to 1 with plus plus I and I plus plus. What does I plus equals to 1 do? I plus equals to 1 increments I by 1, just like I equals to I plus 1. Its value is the new value of I after the increment. Example, int I equals to 5. X equals to I plus equals to 1. I becomes 6. X gets 6. What does plus plus I do? Plus plus I is prefix increment. It increments I by 1 and yields the new value. This is exactly like I plus equals to 1 in both effect on I and its value. Example, what does I plus plus do? I plus plus is postfix increment. It increments I by 1 but yields the old value. Conclusion, only plus plus I is exactly the same as I plus equals 1 because both increment I and return the new value immediately. This is the correct answer. I is increased and yields back the new answer. I is increased but yields back the old answer and increases later. And finalizes the increase later. Rephrase my answer here. Okay. I plus plus I is prefix incrementation. So the I variable is increased by 1 in line. This is the correct answer. I is increased and yields back. That did not copy that. There we go. I plus 1 equal, right? I plus plus I is a prefix increment. It increases the value of I immediately and returns the new value, which makes it behave exactly like this. Nice. All right, 14. We're almost there. Supply parentheses to show how a compiler would interpret each of the following expressions. Okay. Let's do A. So A would be parenthesis A times B minus C times D plus E. And then it'd be like this. B would be A divided by B so this would just go in line, right? Right, modulo by C divided by D. And we need two prefixes out here. C would be negative A minus B plus C minus plus D. So it'd be A in its own parentheses minus B, right? And then you would add C to that, and then minus positive D from that. Perfect. So this parenthesis would go with here, this one goes with there, this one goes with there, this one goes with there, this one goes with there. They're all close. Nice. Okay, and D would be A times negative B divided by C minus D. So you would do this, then you would do this, then you would do this, then you would do this, and then you would do this. So it'd be that, this, and then the final. Perfect. I think that is correct. So let's take these. How do my look? Your parentheses are technically correct. Cool. Yeah, so I just kind of did a little bit overkill, it said. Got it. This would be A times B minus C times D parenthesis plus E at the very end. Okay, so you could do it like this, right? And then this one, it'd be 3 out front, A divided by B modulo C parenthesis divided by D parenthesis. Yeah, that's right. And this one, be 4 out front, nope, 3 out front. Oh, because it just does this one by itself like that. Oh, okay. And then in this one, probably do the same. 3 out front, A times parenthesis minus B parenthesis divided by C parenthesis minus D parenthesis, yeah. Cool. Yep, those are right. Nice. Awesome. All right, last one here. Phew. Okay, give the values of I and J after each of the following expression statements have been executed. Assume that I has the value of 1 initially and J has the value of 2. Give the values of I and j after each of the following expressions. Okay, gotcha. So the thing is are we calling all of these sequentially, or are we doing I is 1, I is 2 for each one of these? Yeah, I think it's for each one of them. I don't think we're going to call these like sequentially. I think we're just trying to give the value of with what it would be, right? I hope so. It's a little bit unclear. So A, which is I plus equals to j, would result in I is equal to, so if I is equal to 1, let's say I is equal to 1 and j is equal to 2, and these are both integers, right? So I, in this case, would become plus equal to j, so this would be 3, and j would equal to just 2. B, where we have I less less, so this is postfix, so I think because it's by itself, this would still move I less 1. So I think what it would do would be I is equal to 0, j is equal to 2. C, I times j divided by 1. So I think I is going to equal to well, we're not actually assigning I and j to anything, so I would equal to 1 and j would equal to 2. Because we're actually not overriding their values anywhere and saving them. Same with this one, except for here. So in this one, D, I mod plus plus j. This would give us I is equal to 1 still. And then j would go incremented to value of 3. So after execution, I would be 3, j is 2. Perfect. Oh, okay, so keep I and j 1. So does it? I think these are unrelated. I think each line is unrelated. So keep I and j 1 and 2 each time. Okay, so I in A would be 3 and 2. Perfect. In this one, I starts at 1 and becomes, oh, is it plus plus I? Oh, it's minus minus. What? Oh, it got all screwed up, that's why. I minus minus. Whatever, I'll give it this. There we go. So 3, 2, perfect. This one be 0, 2, perfect. 1, 2, perfect. And ooh, Oh, sorry. I forgot the J here. I was right. Nice. Okay, cool. That solved 15. Hey, Wes on Kent, how's it going? I appreciate you for joining me on Twitch. If you're on Twitch and are new, consider following along. It's completely for free. I stream myself, teaching myself computer science and programming almost every single day. Got a degree in human biology and a minor in chemistry that I graduated with back in 2021. And I work as a formulation chemist for a biotech company. Currently a scientist 2, kind of approaching the scientist 3 level. Honestly, I'm kind of just I'm kind of shooting my own self in the foot for promotion because if I get promoted, I have to like start doing more and more like administrative, like paperwork management type of stuff, like reviews and things like that, like batch records and paperwork reviews, and I would start removing myself more and more from actual science, like lab work. So I'm a little bit torn to like I'm at this crossroads of like, okay, if I keep going upwards in their their promotion cycles, then I'm just gonna get stuck like sitting more and more at my desk and less in the lab doing cool things, being able to code, being able to script, like and build things. Like now that I've actually gotten that ability to do that in my work, that they've been allowing me to code and build stuff. And so like yeah, I had a conversation with them. I'm like, I talked to my manager, my boss's boss, and I told them, I said, because they do recognize, they recognize, they tell me like, hey, we recognize that you're a really smart guy. We know that you can code, that you can build these cool things. Like I built like an automated, I went to my company, I told them, hey, we have to formulate and compound these matrix mathematical like yields for theoretical blends of serum to hit like a target range of analyte suites, like a sweet range of analytes, like cholesterol, protein, in certain various kind of analytical ranges. And I said, and I went to my company. I said, hey, like I've been teaching myself programming, and I want to take a stab at trying to automate this and save us money by having like a most optimized the solutions, like the combination to yield the predictions we're wanting in the most optimized format for like first expiration, first out, and have a computer do it for us to have it be optimized, save money on serums, and also save money on like labor costs because you're no longer having to spend hours manually having to compute these and then having like reduced error. So I went to my company and my boss's boss and their boss, and I said, hey, I can program now. Can you guys give me some resources to try to figure this out? And so this last summer, I worked with a guy in a different division, and him and I wrote up an algorithm for actually doing it, and we were successful. We figured it out, and we wrote this linear programming algorithm that was able to compute these theoretical yields for a couple different optimization models. And it's really nice. It does like a single level, like a low and a high for concentration, so and it'll like factor against one another for a multi-level versus a single level. And it gives you it basically just tells you add this, add this, add this, add this, add this, and in the combo you'll get out this, and in like a very optimized format. And anywho, where I'm going with this is I've been telling my work in my like one-on-ones and stuff and my management, they've been really pushing me to try to go to the next level. They've been really like wanting me to like try my best to be like a trainer. Like I do train and I do when people ask, but a lot of my work is very like independent because I work very well by just kind of giving like an advanced or a hard task and saying, hey, just go take care of this and get it done by this date. I'm very good at like organizing all my things, working with the cross divisional departments, organizing everything from QA to QC to chem stores to everything, and then just going and performing the sequences to actually compute the formulation and go and do it in the lab and build it and then get the product out in the timely manner. But my management has been pushing me more and more to try to like adapt other people into that as well, and to kind of be more of like a leader and like role model within that. But it makes it a little bit difficult because I can't move as quick, right? But honestly, I'm a little bit apprehensive though, because they're wanting me to, I can just see the writing on the wall, you guys. It's like, the more and more that I would get involved in that, the more and more I would have to remove myself from the lab and do paperwork and check people's math and check people's paperwork and data and like do a lot more administrative stuff. And yeah, and so I'm quite torn. Like I obviously want to get paid more and grow, but I told them, I said I really have no interest in like doing management stuff. Like I'm a scientist. I like math. I like science. I like programming. Like I like lab work techniques. Like that's what I excel at. So if you start removing me from that, like I don't know, it might be not what you want. It might not be the best value I can provide. So I kind of put my foot down. I said, if you're gonna move me forward, it needs to be something that's like aligned with my skills and what I'm good at here, because I can. And I don't know. We'll see what happens. But, how long did the code take to code this? Oh, the algorithm. So I started brainstorming at the beginning of the summer, kind of developing and putting together some basic kind of objects and getting all of my classes organized for how I wanted and what kind of parameters I wanted to track. And then, I was busy, building products and doing my normal job throughout the summer. And then I had some time when I got finished with a build in September to kind of sit down and actually spend a couple hours a day working on it. And we were able to actually write the algorithm pretty quickly in like only like 2 or 3 sessions, hour-long sessions. It only took us about 2 or 3 hours to write the algorithm together. And then I worked on it for a couple, quite a substantial more time, kind of optimizing it, fine-tuning it, incorporating it into my data objects, and then actually running the simulation all together. Because he didn't know how to like run the simulation. He just helped me with the algorithm part, and then I took that part and then stuck it into like our actual what we do as chemists. And then I took about a month, like not a month, a couple of weeks on and off of time, a couple hours every day, building out a GUI. So I built an entire graphic interface that loads products via CSV and loads serums via CSV and displays them into a matrix grid in the GUI. It has logic gating for single versus multi-matrix, as well as like an endogenous factor, which just means that if your serums or your serums have pre-existing data values, so that we can factor down the target ranges by those pre-existing values to compute a delta, and then take that delta, stick it back on with the endogenous to give you your total output, if that makes any sense. So just think about like, oh, I already have some stuff in here, so I don't need to target the full target. Let's just reduce the target down by what I already have, and then target a new target that's the compensated difference, and then add that back on. So it does that dynamically as well. It's pretty cool. Honestly, like I think the program itself is a pretty valuable program to the company in terms of like monetary value. So it'll be kind of interesting to see what happens on my review. Hold on, my headphones died. So it's gonna be pretty interesting to see what happens in my review, if they value it and if I can prove that it has value, because I'm gonna use it here in my next formulation, and I'm gonna show them how much time it saved me, how much serum and substance it saved me, and how accurate it was. And then I'll present it to them as kind of like a proof of concept, and I want to see what they say. I might swing for the fences come bonus time. Anyways, Tim said he would fold after seeing the bag. Yeah, dude, it's tough, huh? It's tough, my boy. All right, you guys, this was fun. We streamed for 2 hours and 30 minutes, completing the exercises for C Programming, A Modern Approach, Chapter 4. Those were pretty abundant. There was 15 exercises here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 exercises. We have 6 programming projects that we'll get into next time. These are like legit just like programming projects, like practice problems to do, not like conceptual based, like, oh, what would the output be of these scenarios? It's actually like word problems to, write some scripts and stuff. So these ones will be fun to get into. Thank you, Wesson. I appreciate you. I appreciate it. That's so kind. Yeah, we're at 3720 subs. So if you guys are new here and want to follow along, please do so. Appreciate you guys being here. You guys are awesome. I need to be better though, because I said I was going to do a morning stream today and I did not because I slept in. Oh gosh. I know, I'm sorry. So tomorrow I'm going to set a goal I'm going to set a goal to stream the programming projects in the morning. I'm going to try to finish the programming projects in the morning, at least like a 2 hour stream in the morning. I'll take a break. I'll come back and we will either read chapter 5 or we will watch the MIT 6.002, 60002 lecture 10 that we're on. Either one of those, I can't decide. But I feel bad because I let myself down today, honestly. I feel a little bit self-guilt because I told myself I wanted to do a double stream to try to to read a chapter and finish these problems, but I did not today. Kind of let myself down. Annoying. I need to be better. What time do I usually stream? I stream usually every day around 7 p.m. PST after work, but on the weekends it's kind of random. So it can be a little earlier, a little later. It's really kind of honestly whenever I wake up. The weekends is I really use the time to just catch up on a lot of Z's because I only average about 6 to 5 hours of sleep a night. And so by the time Friday rolls around, I'm pretty burnt. And then like so I do take advantage of the weekends to try to catch up on my sleep, which makes it hard to because I wake up like really groggy. I'm like, oh gosh, like, oh, do I want to code? So it takes me like an hour or two after I wake up to like get waken up all the way. I don't know, dude. Excuses, excuses. Let's take a peek at some of these programming projects. Write a program that asks the users to enter a 2-digit number, then print the number with its digits reversed. Oh, this is so easy. Read the number using %d, then break it into 2 digits. Oh, it wants us to use the modulo. Ah, cool. That's cool. So it wants us to use modulo to actually break the values into its denominations, right? Or like magnitudes. So that'll be fun to do. To handle 3 digits. Right at the bottom. Cool. This one's will be fun to take care of. You have to watch ads. You can always I'm not sure if it's allowed or whatnot. You guys just flip over to the YT, and then kind of flip flop back and forth. Honestly, I think I might just turn off the ads like in general because like I YouTube is pretty predatory with its ads recently, and it's like honestly, as a viewer myself of content, I am really frustrated with the amount of ads that we're seeing. So I've been actually removing the mid-roll ads from a lot of my videos to just be pre-roll and end-roll. But even then, I'm considering just removing ads altogether. But I don't know. I mean, we've only been streaming for like about a year now. Um, yeah, about a year now, and we've made a whopping $100, baby. $100. We made $100 in 1 year streaming, so it's not even worth it to keep the ads on, in my opinion, at the moment. I might just turn them off until we get bigger, and then it actually makes a difference because right now it might just be hurting us rather than helping us. Um, but I don't know. I'm confused. I don't get any ads. I have 5 ad blockers. Oh, there you go. That's probably why, Tim. Come on. Yeah, I'm thinking about just turning them off, to be honest, but I don't know. $100 is better than no bucks, that's for sure. But we've spent like probably like a good 1,000 hours streaming. Not even that, no. Probably like close to coming up on like 750, maybe 1,000 hours. So no way. If we did every day for a year, we have 400 streams, I think, on the channel. If every one is 2 hours, that's 800 hours. So yeah, coming up on 1,000 probably. I have 160 block. Just keep going up. Well, should we try these or should we watch like a video? Are there any like cool programming videos we can watch together before we go? Um, let's see. Is there any like videos we can watch on my page here? Any good suggestions? Hmm. Not really. Nothing looks that good. Okay. Yeah, I think I'm gonna call it here, you guys. Thanks so much for joining me today. I really appreciate it. I'll be back tomorrow morning. I promise. I'm gonna try my 100% to stream tomorrow morning and get the best stream of all time is still Leak Code plus your mom. That one was good. We haven't done Leak Code in a long time. Could do Leak Code. We haven't done Leak Code. I'm anti Leak Code. No. All right. I'll see you guys tomorrow. Thanks so much for being here and hanging out with me. I'll stream tomorrow morning and we'll complete these programming projects and then either jump into chapter 5 or watch the next video of our MIT 60002 lecture and continue on with that course. Um, yeah, we need to revisit Introduction to Algorithms again and complete those post chapter questions and stuff. We've been slacking real bad. So I'm gonna try to make it a real goal tomorrow to have a good, productive coding day. So please hold me accountable in the Discord, and I'll talk to you guys tomorrow. See you guys tomorrow. Bye.